Hey everyone, and welcome to The Explainer. Today, we're tracing a path from the foundational philosophy of the human mind all the way out to the absolute bleeding edge of modern quantum physics. We're going to explore how the universe is actually constructed, what consciousness really is, and how those two things might just be inextricably linked.
So, what if reality literally doesn't exist until you look at it? I know, it sounds like a riddle, or maybe the plot of a late night sci fi movie. But this single question sets the stakes for our entire explainer today. Because if the mere act of observation is what cements the physical world into place, well, then our entire understanding of reality, physics, and our place in the universe might be completely upside down.
All right, here's our roadmap for today. We'll kick things off with the mind-body mystery. Then we'll scale way down to minds in the microcosm. From there, we'll zoom all the way out to the universal cosmic mind, followed by testing reality in the lab before we wrap it all up with the future of reality. Let's dive in.
Okay, starting off with section 1, the mind body mystery and the hard problem.
For centuries, the greatest thinkers have just slammed into what's known as the hard problem of consciousness. How do physical atoms and molecules sloshing around in our brains actually generate the rich, subjective feeling of being alive? This gap between physical matter and mental experience is so wide and honestly so stubborn that it's driven scientists and philosophers to adopt increasingly radical theories. According to philosopher David Chalmers, we've actually seen a distinct evolution here. Back in the 1950s and 60s, riding high on scientific progress, we embraced materialism, the idea that literally everything is just physical matter. But that couldn't quite explain consciousness. So in the 80s and 90s, we shifted to dualism, suggesting matter and mind are two totally separate things. When that caused a whole host of interaction problems, the 2000s saw this huge resurgence of panpsychism, suggesting matter itself has a conscious nature. And now, well, present day we're seeing the stirrings of idealism, the incredibly bold claim that the physical world is entirely made up of consciousness.
Which brings us to section 2, minds in the microcosm, looking at the absolute smallest pieces of our universe.
So, if we follow this timeline away from strict materialism, what actually happens if we assign consciousness not just to human brains, but to the absolute smallest building blocks of reality? To wrap our heads around that, we need to look at panpsychism. It's the view that mind, or at least a mind-like aspect, is a fundamental and ubiquitous feature of reality. Basically, it's everywhere. Now hold on, this doesn't mean an electron is sitting there feeling anxiety or a quark is doing complex math. Contemporary panpsychists argue that a very primitive basic form of mentality or subjective experience exists right down at the fundamental level of physics. And hey, this isn't some fringe idea. Historical giants ranging from Plato to Bertrand Russell have argued for forms of this exact concept.
In fact, the pre-Socratic Greek philosopher Heraclitus once famously said, "The thinking faculty is common to all." I absolutely love this, because it shows us that this isn't just modern sci-fi or some quirky internet theory. Early Greek philosophers fundamentally believed the universe was infused with a mind-like aspect way before we were ever splitting atoms. All right, moving to section 3, the universal cosmic mind. What if it's all just one giant mind?
Let's completely shift our perspective here. If we can assign a primitive mind to the smallest pieces of reality, what happens if we shift the scale entirely upward? This brings us to cosmic idealism. The definition here is a bit heavy, so let's break it down together. It's the thesis that all concrete facts are grounded in the mental states of a single cosmic entity. This is really closely related to something called cosmopsychism. Instead of tiny microscopic minds building up like Lego bricks to create human consciousness, this view suggests the cosmos as a whole is the fundamental level of reality, and it is conscious. Under this theory, your specific human consciousness is actually derived from a much larger, overarching cosmic consciousness.
So here's the crucial point. Comparing how these two competing theories try to explain, well, us. On one side, panpsychism faces what's called the combination problem. If fundamental particles have primitive minds, how do billions of them combine in your brain to form this single, unified, conscious subject that is you? It's like a giant puzzle. On the flip side, cosmic idealism faces the constitution problem, or what David Chalmers sometimes calls the decomposition problem. If the universe is one giant universal mind, how does it fragment itself downward to constitute the distinct, separate macro minds of you and me? To solve that constitution problem, the philosopher Bernardo Kastrup suggests an analogy using dissociative identity disorder, or DID. In DID, a single human subject fragments into multiple personalities, or alters, which often lack access to the thoughts and experiences of the other alters.
The analogy here, and it's a wild one, is that the universe itself is the single subject undergoing a sort of cognitive fragmentation. You, me, everyone else, we're simply cognitive fragments or alters of a single cosmic subject, completely unaware of the broader cosmic experiences happening outside our specific little bubble.
Okay, section 4, testing reality in the lab. Let's take this into the real world. As fascinating as all that philosophy is, I know exactly what you're thinking. You're sitting there asking, but how do we prove it? How on earth do we take these grand, sweeping ideas about reality and consciousness and actually test them in a lab? Well, the theoretical foundation for doing this lies in something called the Leggett-Garg inequality, devised back in 1985. You might have heard of Bell's inequality, which tests particles separated in space. Leggett-Garg is different. It looks for correlations between measurements of a single object over time. By testing whether an object follows classical rules or quantum rules over a sequence of time, this inequality can literally tell us whether realism, the idea that objects have definite properties independent of us observing them, actually holds true in the everyday macroscopic world. And to test this, we have to scale things way up. To put this in perspective, we're talking about an object 100,000 times more massive than the objects previously tested in similar quantum experiments. Theorist Shugato Bose at University College London, along with his collaborators, is proposing an experiment using a nanocrystal to do exactly this. Guys, this is a massive leap. We are literally trying to drag quantum mechanics, which usually only applies to the tiny, invisible microworld, kicking and screaming into the classical macroscopic world.
Let's walk through the steps of this groundbreaking UCL experiment because it is brilliant. Step 1, they trap this massive nanocrystal in a well, creating a simple harmonic oscillator. Step 2, they let it move back and forth, swinging just like a pendulum. Step 3, here is the absolute genius part. The detector is set up to measure only one half of the trap at a time. Step 4, by doing this, they watch to see if the wave function collapses. It's essentially a high-stakes quantum game of hide and seek. See, if the particle is acting according to quantum rules, the simple act of not seeing it in one half of the oscillator tells us that it absolutely must be in the other half. But because of quantum uncertainty, merely gaining the knowledge of its position, even without physically touching the thing, collapses its wave function. This non-invasive measurement literally injects the particle with momentum and alters how it oscillates. I mean, just knowing where it isn't changes reality. How crazy is that?
As Professor Shugato Bose points out, we don't observe and then we suddenly take a snapshot observation. To make absolutely sure that the system isn't being physically disturbed by the measurement itself, what critics often call the clumsiness loophole, the researchers will actually throw out all the data from the times the crystal is seen by the detector. They only keep the data where it isn't seen, perfectly guaranteeing that the measurement is purely non-invasive. The observation is entirely about the absence of the object, yet it still dictates the object's physical reality.
Which brings us to our final section, Section 5, the future of reality. So, what's next? So what happens if this experiment actually works? What happens if this swinging nanocrystal proves that quantum rules apply to macroscopic objects, and that observation truly defines their state? Well, this matters immensely, and here's the big so what you should take away from all this. First, if the experiment violates the Leggett-Garg inequalities, it literally breaks the concept of macrorealism. It proves that everyday objects do not have definite states until they are observed. Second, it unites quantum mechanics with that philosophical concept of idealism we discussed earlier, giving us physical evidence that mind, or observation, is fundamental to matter. And third, it forces a complete redefinition of observation and existence itself. The physical world might truly, actually, be dependent on a conscious observer to cement it into reality. We've traveled all the way from the ancient musings of Heraclitus to the laser-guided quantum traps of modern laboratories. We've seen how science and philosophy are converging on the absolutely astonishing idea that consciousness isn't just a random byproduct of the universe, but the very foundation of it. So I want to leave you with one final provocative question to chew on today. If reality requires an observer, and the universe is indeed just one giant fragmented mind, what does that make your next thought? Thanks so much for exploring with me today, and keep questioning reality.